Thank you, Chairman, fellow speakers, distinguished industry leaders, future leaders, my ex-colleagues from ONGC, ladies and gentlemen. It's made a bit easy for me, Dr. Reddy. I do realize that I represent a stream or a subject which is typically a nut, bolt, brick, mortar type of work. Of course, that has been transformed digitally significantly, and I'll touch upon that. But this subject is also from the standard list from organizers, possibly with the belief that I, as a minor diversity, bring to this exotic digital spice box a very conventional masala to you. So I'll speak to you on the presentation. Of course, these are my views. Reliance Industries is not responsible for what I say, but I'll be speaking responsibly, believe me. So my subject, I'll just set up a scenario that what exactly, like our chairperson has said, that the cementing integrity, the cementing is the so foundation of well integrity. The well integrity is so foundation of the healthy production of oil and gas is so foundation of human civilization. So ultimately, I'm taking a credit that we are the one who lay the foundation for energy flow all over to the world. And this is the cement, which is a secondary or primary barrier, which comes into the direct contact of formation, all the formation, chemistry, depletion, temperatures, fluctuations, and all corrosive elements. So it has to be robust, and cement is indeed a good barrier, and that is how I'll share that how it works out. Let's look at oil and gas leaking worldwide. This is about 4 to 5 year back scenario, and about on an average 19% oil leak from all over the production wells, which is 1 in 5 wells. You might be interested demographically that Southeast Asia and Latin America has a more than fair share of leakages, whereas the Canada, US, and the North Sea are doing it better. I don't have data for India. I was overseas. A bit about me, a quick one. I'm in cementing for the last 38 years. From the day one, I'm cementing. I've cemented for ONGC, Halliburton. I have worked for Kuwait Oil Company for 9 years. I was in Abu Dhabi for Halliburton. Then I worked for Petronas in Kuala Lumpur as their headquarter SME. And then I joined Reliance. So coming back, cementing has much less share out of this. So the distribution is almost 1/3, if you can read it, is downhole safety valve, 1/3 is wellhead, 1/3 is tubing to annulus A. So the only 8 to 10% is the sustained casing pressure, which is 8% of 20%. Hardly 1.6 to 2% of the wells leak due to the cementing. But we get more than our fair share of blame. So let me explain you. And we will concentrate on the technicalities of cement. We will evaluate it as a barrier, how cement performs as a barrier, what are the leakages path. And once we know the problem, and knowing the problem is more than half a solution. When you can map the problem, when you know what can go wrong, then you have a ways to look at how you can fix it. So this is how we approach. So this 2% mainly is because of the not right product selection, but it is mainly about not engineering the job. And we take pride that how we cement, the very basis of design of cement is very important. It's no longer you just mix the sack in water and pump it and run the casing, you are tired, let's have WOC. I'm sorry the drilling colleagues, but it has to be used to be that way, but not anymore. This has to provide a zonal isolation. It has something very definite objectives to deliver. So very holistically, this is a well life cycle, starting right from your characterization and it goes to the production. Or if you want to look at it a different cycle, so this is more with the well cycle. So well planning, or you want to see it from the this well integrity management system, WMS system, wherever you look at it, right from the well planning, well engineering, well drilling, well construction, the cementing is involved. And then well is handed over to the production. Then it produces for many years. Then it might come back for intervention, work over, then it goes back to production. But then the workover and intervention also involves intensive cementing, and then ultimately goes for plug and abandonment. The cementing is a part and parcel of oil well drilling. So I'm just trying to set up where the cementing is involved as far as well integrity is concerned, whether it's a producing well or it's an abandoned well. You have all the three places, secondary and primary, you have cement which directly plugs all the resources. It makes sure that no hydrocarbon comes out. These are typically my thoughts that why leakages happen. Let's spend a minute here. Normally, whether it's a BOP or a valve or Christmas tree, but I'm more concentrating on cement. Why the valve barriers fail? This is a very conceptual. Possibly at the design stage, we didn't imagine the boundaries, the assumptions were not very correct. And then we didn't design what the well is experiencing in the entire well life cycle. You must be realizing that an HPHT well passes through a lot of thermal temperatures, then cyclic temperatures, when it's cooled down, when the brine is pumped, when the hot gases come. In MJ and our places, in a Reliance, we are producing a gas almost 156 degrees centigrade. And it passes through the seabed, 3 degree, comes to the surface, and then entire production cycle, then everything is hot up. Then there is a wellhead growth, there is annual pressure buildup, and there is a lot of stress on cement sheet. So it needs a very careful deliberation. If you don't design it properly, it is bound to fail. Another one is, it is exposed to the changed condition like I outlined. Another one is that we end up using it differently what it was originally designed for. I have seen a production well after 8 years subjected to as an injection well. Oh, that's not right. The production well in Petronas, we used to design for injection with a planned injection profile later. So the wellhead pressure, the flow, the pressures, the sustained injection needs a different type of cement isolation. So those are typically old well in a depleted reservoir can be used as a CO2 injection sequestration. But it cannot be done unless cement is designed for CO2 exposure. So that entire holistic risk analysis of barrier needs to be done, or the cyclic stresses are done. So what do we need to fix those losses? We need to have something in a DNA of the well which takes care, just like an antibody within the well, and that is well integrity. And well integrity is not something, a substance. It is everything it takes to ensure that the uncontrolled hydrocarbon doesn't releases, be it technical, engineering, operational, organizational, vision, everything is part of well integrity. This is as per NORSOC. So let me take you to theoretical possibilities of leakages related to cement. And then we will concentrate what it takes to fix those leakages and how to do it. I'll just outline. So one, very obvious, the outer side between cement and surrounding rocks, it can leak. And what are the reasons? Washouts, not properly drilled hole, not cleaned up holes, or we have a poor centralization. The cement doesn't get an opportunity to take the place where it is intending to, or the mud is not conditioned and you have a huge dry cakes which dehydrate later and create a passage for surface gases or shallow gases and those things. Between casing and surrounding cement, which is more obvious, which is evaluated. The earlier one is evaluated by the variable density log, VDL, which we can figure out. This one is from the CBL or a lot of other unconventional wells. But microanalysis is created, whether a dry or wet. It's mainly because of the ballooning, because of the difference at what internal pressure you cement it, what kind of internal pressure casing experiences while cement is in place, and then we change the pressure. From high mud weight, we change to low weight brine. Then the casing tends to shrink, and then the microanalysis is created. So similarly, then between the plugs and the shrinkage, this is about abandonment. And this is, we are not using the expanding material or something against the shrinkage or poor plug placement, or there is a channel between. Is it for me?
Yeah, 2 minutes, please.
Left. Really? Okay. So I'll go through. And then the slurry design is used for the kind of gas titration and gas migration. So I'll just quickly pass through. So how do we fix it? How do we get rid of all those unwanted things? Do it right first time. And by what we need to do is to do a few of those things so that bring the well integrated well. Now let's see the performance. So when we see functionality, reliability, survivability, or all those of cement, it scores pretty well. It can undergo a permafrost to a kind of geothermal conditions. It can work underwater. It doesn't need air. It works in aqua. It is a very high strength, very low permeability. It works very good as a barrier. So let me see what factors affect cement integrity. The mechanical factors, we have a very low tensile strength, then the cracking happens, the disking happens, the microanalysis happens. We can look at softwares. So I will touch that where digitization is happening in the cementing. So we have a very advanced computational fluid dynamics thing. We can see the temperature thinning. The advanced softwares calculate the change in rheology because of temperature. The cementing companies have a huge database. Those are interconnected, and all those of softwares. And we use flexible cements, resilient cements, and high compressive strength cements. For thermomechanical, we use something with low Young modulus, better tensile strength cement sheet. We use nanoparticles within the cement, which are nano swell packers. Because of the methane, they can expand. And these kind of mitigations can be take place. So this is the roadmap, how to go about it. First, we have to develop a cementing BOD, and then we have to integrate all well objectives. It's a collaborative process from G&G production. And then check, this is the simple formula flow process. And I'll just touch upon what is the basis of cementing design. And this is the flow process, how we design a cement system. And as you can read, and for the lack of time, I cannot explain much, but these are the indicators of successful cementing. So my question to you, how would you cement? Would you take chances? Or our thousands of year old civilization wisdom says, Upaya purvam na dushkaram sayar. If you place the mitigation in place, if you know the problems, if you map, you go into the details, you design it properly, then it's unlikely that you would fail. And this brings to the end of my presentation. And this is the acknowledgement. And I can answer the questions at the end of the session. Thank you.